Now, of the parts of the circuit that cause resistance, one, and it's not necessarily the close to the biggest one, depending on the circuit, but it's usually significant, is the resistance of a wire. Now, there's a formula here that helps us determine the resistance of the wire. And again, it's not something that we'll do normally, but at the very least you need to consider it when looking at a circuit, or if your circuit doesn't have any resistors, then that will be the resistance that you have, will be the resistance of the wire. So your resistance of the wire depends on your length. So a longer wire means you're going to add more resistance. It also depends on the resistivity, and so this symbol rho represents the resistivity of your wire. In other words, how good a wire is it? If you're using a really cheap material, then it has a lot of impurities, it's not the most conductive material in the world, it will have high resistivity. If you're using something that's gold or gold plated, it'll have much less resistance, and so it will have a lower resistivity. The other term, though, that actually helps with lower resistance is the cross-sectional area. So by using a thicker wire, you're providing more room for the electrons to go through, and so it won't heat up as much, and it will have less resistance. Now, this resistivity I was talking about is also temperature dependent. This formula is not something that you need to know, but you do need to know that when a wire gets hot, then it gets harder for the electrons to flow through, and there will be more resistance. Now, the source of the greatest resistance in a circuit will be a resistor. Not all resistors are set up this way. This is sort of the general way of doing it. Most resistors do sort of look like this, where you have colors on one side, and they tend to be 4 colors. Now, the first color represents a number, and then the second color represents another number. The third color represents the number of zeros, and then the fourth color represents the uncertainty. So to read a circuit like this, you have to look at your color code chart that you'll have in your notes, or you can look it up online. And the first one is red, and red represents 2. And the second color is blue, and the color blue represents 6. Now, number of zeros, we look up green. Green is 5, so you write down 5 zeros, 1, 2, 3, 4, 5. And so our resistance is 2,600,000 ohms. Now, we tend to use prefixes. The most common prefix actually is the kilo ohm. So this could be 2,600 kilo ohms, or we can use the mega prefix, 2.6 mega ohms. Now, we have this uncertainty, so we add plus or minus 20%. Now, for uncertainty, if you see gold, it's plus or minus 5%, silver is plus or minus 10%, and if there's no color there, or no band at all, and they're kind of drawn in the band, but if all you see is 3 colors, that represents no color, that'll be plus or minus 20%. Now, if I ask for a range, then what we have to do is then, and I'll use the kilo ohm here, say 2,600 kilo ohms plus or minus 520 kilo ohms. So then our range is 2,080 kilo ohms to 3,120 kilo ohms. Now we look at circuit diagrams. When we do circuit diagrams, there'll be some symbols that you have to memorize. So you just have to know them, so when the time comes, you'll be able to draw them. There's the cell, there's a battery, a resistor, and be careful with the resistor to just draw 3 or 4 zigzags. Try to be neat, don't go crazy with the zigzags. Switch, always draw it open, not closed, so that I can see it. There's a lamp, And when we use LEDs, we're not going to actually spend much time on LEDs, so you can just draw a lamp when we do that. Capacitor is a small component that actually stores charge. A voltmeter, and so notice with a voltmeter it's got two leads. Remember, a voltmeter measures potential difference, and so it's always attached across a circuit, across a battery, across a resistor, and so the two arrows there would go across a resistor if that's what you're measuring. And the ammeter would go in the circuit, so we have the symbol A. When we draw a circuit, try to follow my procedure, and there's not a specific order that has to be done, but it'll make life a lot easier for all of us if we all follow the same way, and that way when you do your work you can compare it to the solutions, and it'll just make life a lot easier. So I'm going to ask that you always start by drawing out a battery. So in this case I'm going to draw a 12 volt battery. Use straight lines. Start at the positive side of the battery, right? And the long side is the positive side. We're going to go counterclockwise. Always write in the resistances for your resistors. Always use straight lines. For parallel resistances, you can draw it like this. Again, there's no set way. The important thing that I'm going to ask is that you always do it in the order that I give it to you. Go counterclockwise, start at the positive side of the battery, and always do it in the order that I give it to you. It doesn't have to, but again, it makes life much easier if we do that. So here, I've labeled everything, and that's an example of a circuit diagram.